Hey everyone, welcome to today's video. So whenever system fails, we look at obvious layers. We look at application, we look at databases, we look at infrastructure. That is where we start most of the time. But production system don't break where you think it will. They break in dependencies, which you assume are always working. So DNS is one of those dependencies. Most of the time, it is not monitored properly and it is not well thought before defining any architecture. It just works most of the time until that day when it fails. And whenever it fails, it does not just degrade your system, it completely disconnects you and your service from everything. So in this video, we are going to discuss about some of these important principles which makes DNS powerful, and we will discuss a mental model which you can develop to debug any DNS issue in production. By the end of this video, you will know exactly how to debug that and which layer to check, which command to run, and how to trace any DNS failures step by step in production. So without any further delay, let's jump into the video. So this video, we are going to divide into a couple of sections. So the first section is to understand what exactly is DNS and how the resolution chain works in real time. We have created a scenario where we will create an artificial failure of DNS, and we will understand how exactly it is working. Followed by, we will understand about the dig tool, which is the single source of truth for tracing any DNS queries or DNS chain, which runs from a local server or from a DNS server. Then we will create a couple of artificial failures with regards to DNS, and we will try to troubleshoot with defining a baseline for tackling step by step. Next, we will understand some of the common issues which we see in production with regards to DNS. We will discuss about it. Finally, we will discuss about a takeaway which you can take it out from this video, which you can apply immediately whenever you are getting into a incident with regards to DNS and troubleshoot accordingly. So let's see it in action. So the first question is what DNS actually does. So DNS stands for domain name system, and as you know, machines talk to machine using numbers, and those numbers are nothing but your IP addresses, and your application knows how to talk to these IP addresses. But as human, it is very difficult for us to remember all these IP addresses, for which we use some of the meaningful names for a particular service. For example, we use names like google.com, we use like cisco.com, facebook.com, instagram.com, youtube.com, etc., etc. And these names mean nothing to the network. So DNS works as a translation layer, and the main job of DNS is to give you those IP addresses whenever you give the name within the browser or within your command line. It just translates that name within an IP address which your machine can understand. So here, what most people don't know is that this translation does not happen in one layer or within one step. There is a chain reaction or chain of reaction. There are very specifically 3 distinct layers, and every layer can fail differently whenever a DNS issue is occurring. I am going to walk you through each and every layer, because whenever DNS breaks in production, knowing which layer broke tells you exactly which command to run and exactly what to fix whenever you are getting into an incident. So what are these layers? So the first layer is your local cache. So what exactly is your local cache? So whenever your machine needs to resolve a name, the first thing it does is to check for that IP address locally. So let's say you have searched for google.com and it has an IP address for, let's say, 23.72.123.21. And this is the IP address of google.com where it is exactly hosted. And whenever you query for google.com, the answer never comes, or most of the time it does not come from a single server. It can change multiple times because Google is a distributed service and it can be hosted in multiple regions with multiple servers. So whenever you search for that google.com name within your browser, first thing, your OS, what it does, it saves this particular IP address as a list within your operating system as well in the form of local cache. And this local cache comes with a TTL value, stands for time to leave. What exactly is a time to leave? So the DNS answer or DNS result comes with a TTL value, which is somewhere around 300 second to 3000 second. It can be. And this is a timer. What timer? So this IP address, which is getting stored within your cache, this TTL value decides how much time this IP address will be stored within your operating system. So Once it gets resolved, or once Google gets fetched from your browser, from that time, this timer starts up to this TTL value. Once it crosses that TTL value, then the cache gets refreshed and the new address will be again stored within your local cache. So what helps it gives? So whenever you are trying to search for a website or you are trying to do a DNS query, instead of taking much time, once it's saved within your cache, the browsing experience can be fast, and TTL directly impacts how often your DNS lookups can happen. A lower TTL value means there will be frequent lookups, and a higher TTL value means you will have lesser lookups, right? As simple as that. Because whenever you are having a higher TTL, it improves the speed, but it delays your propagation of the changes. For example, let's say they have google.com has migrated some services, or they have done some changes to their properties. So if you have a higher TTL value, it will take a lot of time to propagate that changes or that change to come into the effect. So you will get a delay in getting all the refresh or whatever the changes or bug fixes, if whatever the form to propagate, it will take some of the time or more time than required. So that is why TTL gives or makes a lot of impact when it comes to defining or creating your DNS entries. So that is why it has to be considered while you are defining your DNS values. So that is the first layer. We'll go to the second layer, or the step 2, which we call it as the resolver. What exactly is resolver? So for example, let's say you are trying to reach to google.com. If your local cache does not have the answer, or it does not have that IP address, it will not stop there. So what it will do, it will forward that request to another layer in the form of resolver, and it will send a query to a DNS resolver. So you can consider resolver is a middleman or a server whose job is to find the answer on your behalf. And you don't have to only dependent on your operating system will be immediately transferring that query to the resolver so that it can look for. Now the question is, what kind of resolver you can have? Is it a static one, or all the people around the world will be having the same kind of resolver? The answer is no. So there are typically 3 types of resolver which presents. The first one is your internal DNS servers, or within your local you might be having a DNS server or a resolver. You can host it or you can manage it on your own. Most of the time companies prefer to have their own DNS servers or the resolvers, because whenever you are having lot of internal services which talk to each other in the form of microservices, for example, let's say you have a payment API, let's say you have a database, or let's say you have API gateway, etc., etc. So you want to manage that record within your internal system. So that is why in that case you go for the internal DNS service or the internal resolvers. That is one point of thing. Second thing is your ISVs, or your internet service provider. For example, let's say you have the internet taken from Airtel. So they also manage a resolver, or they also manage a DNS server for caching the IP addresses for all the DNS queries which are made from your system. Or there might be some predefined entries which the ISVs can maintain. So whenever your request goes out of your computer, it first reaches to your public internet or within your router. So that is where your resolver will be resolving the IP addresses, the DNS queries which you have made. So that is why ISV also plays a key important role for impacting your DNS queries or amplifying your DNS queries which you are making. So that is the second type of resolver. The third type of resolver is your public resolvers. Like Google has its own DNS server, Cloudflare has its own DNS resolver. Normally Google's resolver starts with 8.8.8.8, and the Cloudflare's resolvers signifies as 1.1.1. So these are the public DNS servers which is used for public uses. You can also use those DNS servers for working as a resolver or querying for your DNS queries which you are making. These resolvers also keeps its own cache. So it gets query from your machines and checks its cache, and if the answer is there, then it will return the answer immediately. But if it is not finding that answer, it will pass on that particular query to the next step, which we call it as authoritative answer, which is the next step or the third or final step of the DNS resolution, where definitely your query will be answered and you will get your IP address. How exactly it is done? So whenever resolver is not getting anything or it is not finding anything in the cache in its cache, so it keeps on going on hunting for that IP address, and it then reaches to your authoritative answer, where again it goes into multiple steps. The first step, as you mentioned, as you know, resolver starts looking within its cache. If it is not finding, it forwards that request to your root servers, which is the second server. What exactly is root server? It is the top layer you can consider. These are root name servers. In the world, there are total 13 root servers which are there, and these root servers are not only 13 static servers. They are 13 different clusters having single IP addresses, and they are distributed around the world. You can imagine any location in the world, it is there. And I'm not getting very in depth to there. We will discuss in our next videos. Stay tuned for those explanations. We are just focusing the DNS query and the life cycle of a DNS query until you are getting that answer and the problems which occurs in between. So we will stick to that particular explanation. So once it does not find within these 13 root servers, so what it will do is it will just forward that request to the next step, which is our TLD or the top level domain servers. So TLD servers are nothing but the servers with distinguishing with your what type of URL you have, whether you have a .com domain or whether you have .in or whether you have a .org or whether you have a .io, anything else. So if you are searching for google.com, what it will do is it will just forward the request to the .com TLD server, and within that only it may be finding that particular answer. If it is not finding, again it will route to the final destination, which is your authoritative name servers, which is the source of truth for your domain and the IP addresses, and that is the final destination, which is nothing but your authoritative name servers. In this server, there will be actually your DNS records with the name of A records, AA records, AAA records, TXT, SRV, all the records will be defined, and your machine will be getting the IP, and it will forward that request to your browser, and you can reach to your google.com, or you can finally find your IP address which you need to connect for the query which you have made. In our case, we have just searched for the google.com or whatever the website name we have looked for, we will find it that. So right, so that is what about the 3-step for all your query which happens. It is very common, and the problem whenever it occurs, it can happen in any of these layers. We will try to find whenever a problem is happening how to debug it. So how we will do it? So for illustrating this, what we have done is we have created a scenario, and the scenario is very simple. Everything is local. So we have a client which is nothing but our terminal or our browser from our Mac, which we are working with. So what I have done is I have taken a EC2 instance. In that, what I have done is I have created my own website, which I have named it as buildin10-tech.com. Disclaimer, it is not up at the moment, but I have created an artificial website, and I have not registered this domain, or I have not published this domain yet. And it is running on port 8080. I have written it in Python, and this is hosted on an Nginx server where we are running it on port 80 on TCP. And we have a resolver config in this etc resolve.conf. Always remember to find your resolver configuration. You can always define this particular file. As I mentioned, it can be just a list with a name of your server and with the IP address, and everything is local here. So that is why I have configured in this. And what I have done is I have hosted my own DNS server. I have used a service called as Core DNS for hosting my own DNS server, where I have the authority for buildin10tech.com on running on port 53 UDP, and I have a record which I have defined, and I have defined a TTL for 30 seconds. So these are the information which I have created on a single machine. I have not gone for a public resolver or anything. Everything is local. And how exactly it connects? Whenever you try to send a HTTP request, it forwards the request first to your DNS server. DNS server forwards that request to your Nginx, and Nginx forwards that proxy to your Python app, and you get the answer. Same happens for HTTP request as well. It goes via your core DNS and you will get it. Hope that is clear. It's a very pretty simple example which I could have created for the exercise purpose. If not understandable, you can let me know. I can dig deeper how I have configured, and all that information I can provide. Please let me know in the comment box. But for us, the important thing is to troubleshoot the DNS issue. So we will create the failure, 2 scenarios we will create, and we will try to dig deeper to it. So let's see it in action. So this is my website which I have created, and you can see this is how it looks in my browser, and currently it is working perfectly fine. It's just a simple HTML page which is having some basic information, and it is running fine within my URL. So this is just the front end which I wanted to show you. So before we break anything, I will show you how and what every step looks like when everything is working correctly. We will try to run some of the simple commands, not very deeper commands or not many commands. To be frank, there are not many commands is there for troubleshooting a DNS problem. There are a couple of commands which we have, but it has a lot of information. We need to understand each and everything with regards to it so that it helps us to understand whenever it is breaking in real time. So first thing first, if I want to see how my website is looking, first thing what I do is I run the dig command. So dig is the command which you can run for looking for any of the website. So I will run dig followed by the website which I am trying to query. So what it will do is it will give me all the information with regards to that particular website or with regards to that particular DNS. So here there are a couple of steps which we need to understand. First thing is your header. This is the header. Second is the OPT pseudo section, and in that there is a question section and there is a answer section as well. This is the authority section, and finally you have the performance sections, right? So what it says in the header, there is the first layer which will tell you the dig version which is using and which website or which DNS we are trying to query, and the global option CMD, and we have got some answer saying there is a OP code query, and here the important thing is this particular status and the ID. So here the status shows as NX domain. So whenever you are querying for a URL or for a DNS, if it is returning NX domain, you can consider that that domain name, in our case built-in10tech.com, is not registered. So basically when you host a public website, you first try to buy that particular domain from GoDaddy or from Route 53 or any of the DNS provider which is there. You need to buy it. If you buy it, then only that particular domain name gets registered. And for this website, it is not registered yet. That is why the status shows as NX domain, which is completely normal for our scenario because everything is within a box itself. You don't know to worry about, right? So the next option is the flags. So there are a couple of flags, which is QR, RD, RA. So QR stands for your response, RD stands for your recursion desired, RA stands for recursion available. So this is basically a recursive layer. Like if you have Cloudflare or ISP DNS or any kind of DNS. So this is the query which you are trying to give. And in this, we are providing some of the question where what is the question? So what is the question? We are asking for this built-in10tech.com and asking for the IP address of this particular DNS name. We have not asked it directly. The query which we have made, it is automatically have asked for the A record or the IPv4 address for this particular domain name. So that is the question we have asked, right? So the next section is your authority section. We can say it is a .com domain, and it has 900 in SOA a.gtld server.net. This is very important because this response is coming directly from your .com TLD servers. They are basically saying that I am the .com registry and I'm currently not knowing this particular domain name, and this SOA address is a security protocol which is happening for non-existent domains, and we are not getting into it. That is not very much important, but I can understand that from the TLD servers the response has come as not known. So the final section is your query or performance tab. Here we will get overall query time. So in this, what we have the query time. So this is the overall time which it has taken for performing that query. Here is the server. This server, most of the time it is misunderstood because we feel that this is the server coming from our host name which we have requested for. But this is the server for your public resolver because my laptop is using a public resolver, and this IP address belongs to Cloudflare, which has automatically taken as a public resolver, and that is the IP address of the Cloudflare DNS. And when it was triggered and what is the message size and how much it has received. So this is a basic understanding of how exactly it looks. So here, what problem we are facing is we are having the status as NX domain, which is a pain point for us because this domain is not yet registered. That is why we are getting. So whenever you are getting this output, you always come into the conclusion that there is some problem with the domain registry. You should check for it. We will come to that. But this message is very important. And this section, why I have why I have explained is because understanding each and every output is very important. If you understand it, then you can only troubleshoot better. So that is why the overall explanation is. Now, this is what I have got as a normal dig. So the second thing what I will run is I will run a curl command to check whether my service is working or not, or my URL is working or not. So whenever I will run curl, I will see that there is a HTML page which has been written, which is fine. Most of the time it is resolving, then it will tell you the output in the format of curl. If it is not coming, or if you are getting a 500 or 400, then that also will be visible over here, and you can conclude that it is not working. Now it is working. You can consider that this is perfectly fine. So now what I will do is I will run again the dig command, but what I will do is I will pass on my DNS server IP address so that I get answers which I am requesting for. But for your websites, whenever you are querying and whenever it is registered within a domain register, you will get some output, something like this, where you will get the status as no error, which is absolutely fine. And you will get the answers very simplified. Query, you have made one and you have got an answer one, and authority one, and additional one. And there is a warning. There is a recursion requested but not available, which is absolutely fine, and you can ignore it. And you have multiple answer sections, authority sections, which you can see it for getting the further information. And here what I have got is I have got the IP address or a record of my service, which is coming directly from the server. And I have the authority section as well with ns1buildin10tech.com, all the information I have. So this is how normally a DNS query looks whenever you are trying to query in production. And here what section you have to worry about is this status section and the a record in the answer section, and see how overall output has come. You can carve out all the information when you are digging deeper into it, but when you are in an incident scenario, these things you must check before getting into next step. So now we will get into some real problem which can occur in production environment as well. So for example, let's say you have got an incident saying user saying that we are not able to reach to the service, or your service is not accessible, and you are getting issues while accessing it. For example, our website is not at all reachable. So now what I have done is I have created an issue on my own, an artificial issue you can consider. In production scenario, you might be facing the same issue as well. The issue is something like that. Your user have complained that they are not able to access the website, or website is not at all reachable. And many users has reported, and now your job is to troubleshoot it. So before getting into troubleshooting, or you get into the server level, the first layer which you check is your user layer, because that is the first source of truth. How you do? First, you go to the browser, you check for that website, whether it is accessible for you or not. For sure, it will not be accessible. If it is accessible, then you have to wait for that TTL to expire or your cache to expire. Once it is expired, you will also find that issue as well. If you are not finding, then absolutely fine. But don't only judge from the browser. First, check within your terminal. What we will do, first command which we need to check is to ping to the particular website and check whether it is pingable or not. Simple ping command I will run. I will run for ping-buildin10tech.com. This is my URL. And whenever I ping, I'm directly pinging to that particular URL, and I can see the ping requests are coming back, and packets are getting received. And I can see that server is not down, server is up, but something is problematic in the next layer. So server is not the problem. Server is absolutely healthy. I'm able to reach to those servers. TCP connections are working and everything is working fine. Now, the second layer of check, what I will do is I will run a curl command so that I can see my Nginx responses are coming or not, or HTTP requests are coming or not. So curl is taking some time, but it has resolved some output. I can see that there is no problem at the Nginx layer. I don't have to again go to the service. I don't have to restart it. The curl is absolutely returning the output. There is no problem within the curl itself. Next, as a step of debugging, I will go to the DNS label itself. People, what they do is they normally go to the server, they try to do some extra thing, but never do that before validating from your local itself. So what I will do, I will dig to the particular website using directly my DNS server so that I can check what is the output it looks like. I can see from the output that dig is taking little bit time to giving me the output, because DNS query is taking little bit time for giving me the output. And I can see from that itself that there is some issue with regards to DNS from the query time itself, but the output tells you the overall story. Here I can see the dig has happened, one server was found, but connection has been timed out. There is no servers could be reached. And from here, I can get a hint that there is some issue at the DNS level itself. Now what I will do, I will jump into the server level. That is our third step. We checked from the browser, we assume something, then we ran a few commands from our local, and we saw that curl was working, ping was working, TCP connection was working, but DNS queries were not resolving. Now we got into the server. This is where exactly the overall configurations are there, the DNS configurations and everything. So here itself, I will run every commands locally to check where exactly the problem is happening. First thing, I will run for dig command. Whenever I ran the dig command, I saw that the communication to the resolver is getting refused because the communication error to the local host 53. So as I mentioned in my scenario, 53 is the core DNS IP, core DNS port, which is getting connection refused. I can consider that there is a problem with regards to my resolver itself. So most of the time, whenever you run this particular command, it will only tell you when your local resolver is not reachable. Most of the time what happens in your enterprise, you mostly having your local resolvers. If you run the dig command from your servers or from your application servers, from there only your connection will be refused. You can consider that your resolver is not reachable or something is problematic. But you will not stop there. There might be some resolver issue or resolution issue for your website. You don't stop there. What you do, you again dig for a public website. If it is reachable or it is connected to the internet, then you can dig for the google.com, which most of the time gets resolved. And I can see that the communication to google.com is also getting refused, and I can clearly see that the resolver is not at all forwarding the request from my server to the internet. Within my LAN or within my WAN, nothing is getting propagated. Then as a final bullet point, what I will do, I will just, for my curiosity, I will just curl for that particular host name, and I can see curl is not getting resolved, but it was getting resolved from my local host. So I will run the curl command. Once I ran, I can see that it could not resolve the host buildintech.com itself. So clearly the resolution is not working. As a final bullet hit, what I will do, I'll just call to my local host. I can see that from Nginx, the request or HTTP requests are coming back, but the DNS resolution to the CNAME is not at all happening. So there is absolutely some issue at the resolver layer itself. So what I will do, if I have the authority for the DNS resolver to manage, I will just restart the service so that I can bring back my service to my normal state. And again, I will hit the dig command to verify whether it has resolved or not. And here I can see the resolution is now working and the issue is resolved. So this is a step-by-step process which you can approach whenever you are getting into a DNS problem or a website is not accessible problem, and you can dig deeper to it. So these are few of the problems which can occur within your production. We just discussed about two kind of problem. There might be multiple problems which can happen with regards to DNS. But what normally engineers do in production whenever they see a app failure is they directly go for application logs, metrics, pod restart, etc., etc. But most of the time they look in the wrong place. How exactly you can approach to the problem? First thing what you can do is always start at the user layer, where you first check the URLs or website URL within your browser itself. If it is working, fine. If it is not working, then go to your terminal, perform some of the basic commands. First, you start with pinging the website directly. If it is returning successfully, then you can rest assured that there is no problem at the server. Then go in the curl layer, you run curl against your website, see what exactly the output is coming. You can also apply some of the flags to see what exactly the HTTP error code which is returning. From there, you can assume whether there is an application problem or not. If it is returning 200, then go to the DNS layer, run a simple dig command to see what exactly the output is coming. In the dig command, you don't have to understand all the lines very explicitly. If you can, surely you can do. If you don't want to, then always focus on two things: whether it is returning no error, or whether it is returning NX domain, or it is returning something else. If it is no error, means your resolution is working absolutely fine. If it is returning NX domain, then you can assume that there is a problem with your DNS issuer itself. You should connect to your vendor, maybe Route 53 you can check, or you can go to your GoDaddy if some maintenance is going on or not. If in that case also it is not giving any error, if you are getting no error, see what the A record or TXT record it is returning. You just check whether that is the exact server or not. If it is not, then again go to the server layer. You check again the same commands whether it is working perfectly or not. Again, if it is a problem with regards to your resolver, if you have control of it, you can surely troubleshoot on it. Again, disclaimer, resolver config is itself is a beast. There may be multiple things which can be configured with respect to hosting a resolver on its own. There is zone records. Within zone also, there are multiple things which can come. You can surely check with your code base if something has recently occurred or not. If not, directly engage within your resolver hosting team, or you can get in touch with your vendor. If you have taken any third-party resolver from any external vendors, you can engage with them and you can show those proofs which you have got with respect to dig if you find something with regards to problem for resolver. If something with regards to records, first check what record has been changed and why it has occurred. By the meantime, you do this thing, you will surely understand where exactly the problem is happening and which layer is blocking your DNS, to be precise. And always remember, DNS incidents are closed within 5 minutes by engineers who knows this sequence. And for some people, those incidents can take multiple hours if they don't follow this step-by-step approach. As a final note, I want to mention that every URL your app calls, every service to service connection, every health check your load balancer learns, DNS is step 0 for all of it. It runs before any of your code runs. The engineers who close DNS incident in 5 minutes are not just smarter. They just check DNS first. They run dig before they open any of the application logs or any of the dashboards. They read the status before any guesswork can be done by any other teammates. And the status of the dig output tells you everything and tells you exactly where to go, which layer to troubleshoot for resolving that particular issue. If you know the same sequence, you can run the dig command first, then read the status, follow the branch. Every DNS failure, whether it is down, slow, or returning any wrong answer, fits somewhere in that particular model. And that is how you can troubleshoot any of the DNS problem which you can face within your production system. So if this video has changed how you think about DNS, then please do subscribe to our channel and do let us know about your thoughts, how you find our topics which we are covering, and put your thoughts and comments in the comment box. It really gives us motivation to bring this kind of topics in future as well. And please share it within your community. It really helps us to grow, to reach wider audience. And with that, we end today's video. Thank you for watching. See you in the next one.